Hello guys, good evening. You are welcome to my YouTube channel, the Explicit Tutorials. Now please, as you are watching this video, endeavor to subscribe, like, share and comment. Now you have compiled questions on chapter 2 of Chem 113 part 1. Okay, this topic has been treated already, so these questions are exam likely questions. Please listen and listen very well. You know, in every exam, tranquility is required and high level of sagacity and meticulous is what required. So let's take the following questions. The first one says, the heating of dry copper oxide with dry powder is used to determine dash. The heating of dry copper oxide with dry powder is used to determine dash. A. Nitrogen and sulfur. B. Carbon and nitrogen. C. Hydrogen and carbon. D. Hydrogen and what? Sulfur. Please, the heating of dry copper oxide and dry powder is used to determine hydrogen and what? Carbon. Take note of that. Number 2 says, during elemental analysis, the liberation of black precipitate shows the presence of dash. During elemental analysis, the liberation of black precipitate shows the presence of dash. A. Nitrogen. B. Sulfur. C. Carbon and D. Hydrogen. The answer is what? Sulfur. During elemental analysis, the liberation of black precipitate shows the presence of sulfur, which is what? B. This topic has been treated. Alright, it is good you play the video before attempting this question, so if you have read this topic by yourself, so with these questions you know how much you have understood the topic. Number 3 says, the presence of pink or purple color with sodium nitroprusside shows the presence of dash. The presence of pink or purple color with sodium nitroprusside shows the presence of dash. A. Nitrogen. B. Sulfur. C. Carbon and D. Hydrogen. So what is the answer? Please, the presence of pink or purple color with sodium nitroprusside shows the presence of sulfur. So as you know that the liberation of black precipitate also shows the presence of what? Sulfur. The fourth one says, the presence of Prussian blue shows the presence of dash. The presence of Prussian blue shows the presence of dash. A. Nitrogen. B. Sulfur. C. Carbon and D. Hydrogen. Prussian blue shows the presence of nitrogen, which is what? A. Number 5. Which of these is correct when silver nitrate is added to sodium chloride? Which of these is correct when silver nitrate is added to sodium chloride? A. White precipitate of silver chloride, which is insoluble in excess aqueous ammonia. B. Off-white precipitate of silver bromide, which is primarily soluble in excess aqueous ammonia. C. Yellow precipitate of silver iodide, which is insoluble in excess ammonia. And D. White precipitate of silver chloride, which is soluble in excess ammonia. The answer is between A and D. Please, when silver nitrate is added to sodium chloride, there is what? Liberation of white precipitate of silver chloride, which is soluble in excess ammonia. So the answer is what? D. Number 6. Which of these is correct when sodium nitrate is added to sodium iodide? Alright, I'll repeat the question again. Which of these is correct when sodium nitrate is added to sodium iodide? A. White precipitate of sodium chloride, which is insoluble in excess aqueous ammonia. B. Off-white precipitate of silver bromide, which is sparingly soluble in excess aqueous ammonia. And C. You have yellow precipitate of silver iodide, which is insoluble in excess aqueous ammonia. And D. White precipitate of silver chloride, which is soluble in excess aqueous ammonia. Okay, so okay, aqueous, there was a mistake. I would have added ammonia, okay, not just SS aqueous. Thought to have been SS aqueous ammonia. So what do you think the answer is? Is it yellow precipitate of silver iodide, which is insoluble in SS aqueous ammonia, or off-white precipitate of silver bromide, which is sparingly soluble in SS aqueous ammonia? Please take note, when silver nitrate is added to sodium iodide, all right, there is liberation of a yellow precipitate of silver iodide, which is insoluble in SS aqueous ammonia. Take note of that. It is very, very important. Like I said before, I've treated this topic very well. If you think you just can't read the topic all by yourself, it will be very, very good you listen and listen properly to the video. Number 7, which of these is correct when silver nitrate is added to sodium bromide? Which of these is correct when silver nitrate is added to sodium bromide? A, white precipitate of silver chloride, which is insoluble in SS aqueous ammonia. B, off-white precipitate of silver bromide, which is sparingly soluble in SS aqueous ammonia. C, yellow precipitate of silver iodide, which is insoluble in SS aqueous ammonia. And D, white precipitate of silver chloride, which is soluble in SS aqueous ammonia. Please, the answer is off-white precipitate of silver bromide, which is what? Sparingly or and partially soluble in SS aqueous ammonia. Please, the answer is B. Number 8. When a known weight of copper 2 oxide is heated in a stream of carbon 4 oxide, this is dash method. When a known weight of copper 2 oxide is heated in a stream of carbon 4 oxide, this is dash method. Is it Gelder's method, Lassen method, Dumas method, or Cope's method? Please, copper 2 oxide and carbon 4 oxide are associated with Dumas method. So please, the answer is what? C. Number 9. In Dumas method, any trace of carbon 4 oxide and sulfur 4 oxide is absorbed by dash. In Dumas method, any trace of carbon 4 oxide and sulfur 4 oxide is absorbed by dash. A, magnesium hydroxide. B, sodium hydroxide. C, potassium hydroxide. D, calcium hydroxide. Please, any trace of CO2 and SO2 is absorbed using potassium hydroxide, which is what? C. Take note of that. It is very, very important. Number 10. Tetraosulfate 6 and anhydrous potassium sulfate are associated with dash method. Tetraosulfate 6 acid and anhydrous potassium sulfate are associated with dash method. A, is it Gelder's method? Is it Lassen method? Is it Dumas method or Cope's method? Please, the aforementioned two compounds are associated with Gelder's method, which is what? A. Number 11. The function of the anhydrous potassium sulfate in the above method is to dash. The function of the anhydrous potassium sulfate in the above method, which is Gelder's method, is to dash. A, raise the dehydrating power of the acid. B, raise the boiling point of the acid. C, reduce the boiling point of the acid. And D, reduce the dehydrating power of the acid. I'll repeat the option. A, reduce or raise the dehydrating power of the acid. B, raise the boiling point of the acid. And C, reduce the boiling point of the acid. And D, reduce the dehydrating power of the acid. So please, the function of the anhydrous potassium sulfate is to raise the boiling point of the acid. Please, it raises the boiling point of the acid. Number 12 says ammonium sulfate is associated with dash method. Ammonium sulfate is associated with dash method. Is it Jedas method? Is it Lassen method? Is it Dumas method or Kolb's method? Please, it is associated with Jedas method. Now, this topic has been treated completely. If you should log in my YouTube channel, you'll see videos on chapter 1, 2, 3, 4, and so on and so forth in Chem 113. Go through these questions and understand all of them properly. More questions are yet to be dropped on this chapter 2. Now, the next part I'm going to be dropping questions on is isomerism. Isomerism, you know, the ability of organic compounds to have the same molecular formula but different electronic configuration. You say such compounds are isomers. The process is called what? Isomerism. On a broad note, we have two types of isomerisms. We have the stereoisomerism and we have the structural isomerism. We have the stereoisomerism and we have the structural isomerism. Under the structural isomerism, we have the position isomerism, we have the chain isomerism, we have functional group isomerism, and we have tautomerism. Under structural isomerism, I said we have chain isomerism, positional isomerism, tautomerism, and functional group isomerism. Then under the stereoisomerism, we have the optical isomerism and the geometric isomerism. Under the geometric isomerism, we have the cis and trans isomerism. Okay, so I've also done videos on isomerism. So just as I'm saying it, just watch my videos and you understand it properly. Please, thanks for watching. Endeavor to subscribe.